Hi, in this video I'm going to show you guys how a technique to find integrals, and we call this technique the substitution method. So now we are at a higher level of finding integrals, and this technique will make the process a lot easier. Okay, so let's take a look at an example here. So now what I have to do is I need to find the indefinite integral of 3x squared plus 5x, the whole thing to the power of 4, multiplied by 6x plus 5. So what I can do here is I can do this. Right? I can do 3x squared plus 5x multiply 3x squared plus 5x, right? And I can do that 4 times, right? Because I have a power of 4, and then multiply it by 6x plus 5. And then open each individual and just kind of remove the parentheses, multiply every terms, and simply and then combine like terms. Do all that, and then find the integral. But that's going to take me forever. That will take us forever, right? So this is when the substitution method comes in handy. All right. So let's say today I'm going to do this on the side. Let's do this on the side. If I say my u is equal to 3x squared plus 5x, this is my u. Right, this is my u. Now, if I differentiate my u with respect to x, so my du dx will give me 6x plus 5. Correct? And do you guys see something here? What is this? That is my du dx, right? That is my du dx. All right. So what I can do here is this. So now let me change that to blue. This is the same thing as saying, so my 3x squared plus 5x, that is my u. So this is my u to the power of 4. 6x plus 5, my 6x plus 5 is the same thing as my du dx. So now this becomes du dx. And now I have dx. All right. So now we can kind of do this. The dx and the dx cuts out. Right. So I will have u to the power of 4 and du. And this is easy, right? So u to the power of 4. If I just integrate u to the power of 4 with respect to u, so what we have done here is we have changed our variable beginning. At the beginning it was x, but now I have changed it to u. I've changed it to u. Just simply by substitution. Right? I substitute u for my 3x squared plus 5x. Right? Just simply by substitution. All right. So now the answer. If I continue with this, I'll get u to the power of 5 over 5. Right. Plus c. And now, what's my u? My u is 3x squared plus 5x, right? My u is 3x squared plus 5x, so I'll get 3x squared plus 5x over 5 plus c. And that is your answer. Okay? Now, so what we're doing here is we're just introducing a new variable to represent one part of my original expression. So now you might be asking, why did I choose this to be my u? Why didn't I choose that to be my u? Why not? Why can't I do that? Right? So now the reason why I could do it quickly is because I've done it several times, right? So the thinking process would be, if I look at 3x squared plus 5x and I look at 6x plus 5, I see that if I differentiate 3x squared plus 5x, I will get 6x plus 5, right? So this is a derivative of that. This is a derivative, right? And that's the reason why I picked that as my u. And because after I have that u, I can use du dx to represent my 6x plus 5. All right, so that's the thinking process that was involved. Okay. let's take a look at another example. So in this case, I have I need to find the indefinite integral of x squared minus 3x cube root, the whole thing cube root, multiplied by 2x minus 3. Now, if you think about this, so it looks pretty complicated, right? It's pretty long and looks pretty scary. But if you think about it, isn't my 2x minus 3 a derivative of that? Right? This is just the derivative of my x squared minus 3x, right? So what's going to be my u? Right? What's going to be my u? My u will be x squared minus 3x, right? So if I du dx, I'll get 2x minus 3, which is what we have over here. So this is my du dx, right? And that's what I'm going to write later on. I'm going to substitute that with du dx. Now, so this is this. I can proceed with my process. Now this will be my x squared minus 3x. This is my u now, right? So I have u. What's cube root of 3? That becomes to the power u to the power 1 over 3. And this is du dx. And we have dx over here. Now this becomes u of 1 over 3 du, right? The dx cuts out. Okay? Then, now it's a lot easier because we are simply trying to find the indefinite integral of u to the power of 1 over 3 with respect to u. Right? So 1 over 3 plus 1, that gives us 1 over 3 plus 3 over 3, which is 4 over 3. Right? So that will be 4 over 3. And the coefficient will be 3 over 4 plus c. Right? I hope you guys are comfortable with finding indefinite integrals now. Okay, now the last step, remember, substitute my u back. My u is this. So now I'll say this is equal to, my final answer would be x squared minus 3x, the whole thing to the power of 4 over 3, plus c. Alright? Okay, let's look at another one. So here it is. This is the third example. All right. I'll let you. Please pause the video and think about which one is gonna be my u. Is this gonna be my u, or is that gonna be my u, or is the e to the power of the whole thing gonna be my u? Think about that. Okay. See which one is gonna be my u. All right. Welcome back. Now, if I think about this, let's say today I'm gonna try say my u is equal to 4x squared plus 1. So sometimes we might have to try here, try this, try that, right? And for now I'm just gonna try this. If my u is equal to 4x squared plus 1, then if I du dx, I will get 8x plus 1. Oh, sorry, there's no plus 1. I'm just gonna get 8x. Okay. Now this part, this x. Oh, sorry about that. The x over here and the x over there. That's kind of good, right? That's good. But I have this 8. This 8 right there. What do I do with that? If I had an 8 over there, then it's perfect, right? But I don't, right? So how can I take care of it? How can I take care of the 8? So since 8 is something that we don't want it, if 8 is something that I don't want it, then I can say my x is equal to, because right now this is my x, right? So my x is equal to 1/8 of du dx. Does that make sense? I'm just multiplying 1/8 to both sides, right? Multiplying 1/8 to both sides. So my x, which is what I have over here, right? My x is equal to 1/8 of du dx. So now right now I can continue the process. I'm going to reshuffle this a little bit. It will be my 1/8 du dx. This is my x now, right? This is my x. E to the power of my 4x squared plus 1 is my u, so that's my u dx. And let me rearrange this. The constant, I can put it to the front. I get 1/8. I can move them around, right? I can move this around. So I have 1/8 integral eu, and then I have du dx. So this is simply 1/8, and then integral of eu dx cuts out. I get du, and this is easy now, right? This is so much easier. But this is equal to 1/8 just eu plus c. But I'm not done yet. Don't forget to substitute back. Don't forget to substitute back what your original x. So I will have 1/8 e to the power of 4x squared plus 1 plus c. All right. If you're not sure, if your answer is correct, you can always test it out. So let's say if my y is equal to 1/8 e 4x squared plus 1 plus c. My dy dx is going to be, so when I differentiate my c, it becomes 0, so I don't have to worry about that. So the 1/8 is going to stay there, and this is a quadratic inside my exponential, so I'm going to do the outside one first. So the exponential function, derivative of the exponential function itself is same, multiplied by, this is, now I'm going to differentiate the inside, right, the quadratic, that will give me 8x. So the 8 and the 8 cuts out, and I will get x to the power x multiply e to the power of 4x squared plus 1, which is what I have over here. So my answer is good. My answer is good. All right, last example. What? Look at this. This is so chunky, right? This is so chunky. But don't be afraid. All we have to do is to find, just observe carefully and find which one is going to be my u. In this case, I'm going to look at the bottom or the top. Which one do you think is my u? I hope your answer is the bottom, right? Because if you think about it, the power here is 4. If I differentiate that, wouldn't I get a power of 3, right? So my u in this case is going to be 3x to the power of 4 minus x cubed. So if I du dx, I'll get 12x cubed minus 3x squared. And hey, isn't this part, the numerator, that's my du dx, right? The numerator is my du dx, right? So now I can change the whole thing, and I can continue with this. So the 3x to the power of 4 minus x cubed, that becomes my u. And my numerator is my du dx. And I have a dx outside, right? So this is the same thing as saying finding the integral of 1 over u, du dx, and then dx. So that gets cut out. So this is the same thing as saying 1 over u with finding the integral of 1 over u with respect to u, which is simply ln u plus c. Don't forget to substitute back. So that will be ln of 3x to the power of 4 minus x cubed plus c. Just to make sure that my answer is correct, let's try to differentiate that. So if my answer is correct, then when I differentiate this, I should get that ugly chunk. So let's see, dy dx. So here I have a polynomial inside my natural log function, right? So I'm going to do the outside first. So natural log, when I differentiate natural log, it is simply 1 over that, right? I'm not done yet. Now I need to differentiate the inside, which is my polynomial. That will be 12x cubed minus 3x squared. And when I differentiate a constant, that becomes 0. So this will be 12x cubed minus 3x squared. That will be my numerator. And my denominator is this, 3x to the power 4 minus x cubed, which match. So my answer is good again. Substitution, it is a very helpful technique, right? It's a very helpful technique. Please pay attention to your math notations, okay? Your math notations, we need to know our math notations, right? All right, this is it. I'll see you guys in the next video. Bye-bye.